of the I got today on Monday, March 23rd during the class hours. If you want, it might be helpful if you send me any questions you have beforehand, and then we can go over the answers live. But because it was the first time, this seemed a good way of addressing the questions. And I'll also post some practice questions on the ecology, and then I'll post the answers a little bit later today. It's going to be very quick. All right. So, the two main things people want to go through was nitrogen cycle and confidence interval bars. So this is your nitrogen cycle. I took out anything that I didn't think was going to be particularly helpful for you. And let's go over these two terms here. Nitrogen fixation means turning nitrogen gas into a more solid form. So you're taking it from nitrogen gas and you're fixing it into the soil. So you can always think of fixation as you're making more bonds, like when we do carbon fixation. Calvin cycle, you're making from a gas to a more solid molecule, which is glyceraldehyde 3-phosphate. Here you're taking it from a gas and you're turning it into ammonia. And then denitrification is actually the opposite. So you're going to take it from nitrate form in the soil and turn it back into a gas. Okay? And we're going to be using this in our proteins, in our nucleic acids. So hopefully this works. Okay, so here we have our nitrogen gas, and it is going to be fixed in these bean plants. The legumes being bean, not vegetables, for every vegetable, but just the beans, and they have these nodules, and that has the rhizobium bacteria, and that fixes the nitrogen gas. So it's going to add atoms to it, and it's going to change it out of its gaseous phase. All right. You also have some nitrogen fixing bacteria sometimes in your soil here as well. All right. So now we get our ammonium, and then it's going to go through this whole process here after the decomposers. This is ammonification. You get but I'm just going to focus on the parts that you should know. So it goes to nitrite, and then it becomes a nitrate. And that nitrate is what is assimilated by the plant here. That's what a plant can pick up, is the nitrate, an O3 negative. Now, if there's an excess of that, you're denitrifying bacteria, and that turns it back into a gas. So you notice I pulled out a bunch of steps to kind of try to make it a little bit simpler for you to remember, like it pulled out ammonification, etc. Just want you to focus on these main points: nitrogen gas, nitrogen fixation, turning by the rhizobium, turning that nitrogen gas into your ammonium, and then that becoming eventually your nitrates, which plants can assimilate. If there's excess, denitrifying bacteria turns it back into nitrogen gas. Hopefully that was helpful. Confidence interval bars. What we're saying is it gives us a 95% confidence measure that the difference between our means is statistically significant. Okay, that I can make a claim, a valid claim, using that data. So how you're going to do it, you're going to use these formulas, and we've done this. You're going to calculate your standard deviation, and then you're going to calculate your standard error of the mean. I think everybody was pretty well set with that when we did the Q&Q on it and the quantitative test. If you don't remember it, you can go back and watch Khan Academy on it, and that will help you out. For AP Bio, we are going to plot our standard error of the mean here, SEM, as our error bars. When you get to statistics, you're going to use a T distribution table and do true confidence interval bars then, but they don't give you a T distribution table, and it's not part of the curriculum here in AP Bio. We just have you do the standard error of the means as though they're the confidence interval bars. So you're going to go up, whatever your standard error of the mean, up that amount from your mean point, and down that amount, and you'll turn it into an I. And you can do that here on a line graph as well, right? What that means, if the bars overlap, the difference between the two groups is not statistically significant. So you cannot make a valid conclusion. So if you were doing this in an essay, you would say the difference between group A and group B is not statistically significant because the error bars overlap. However, if they do not overlap, you say that they are statistically significant within a 95% confidence. Okay, and therefore you can make your conclusion and it is valid. You should always state your conclusion. So how I can see this on the AP exam? Well, they show up quite a bit. I just giving you 3 examples here. Hopefully this will work. Here we go. So this is from 2017. It's publicly released. So you can view it online and you can see how they scored. So you can see they gave the caffeine and the memory on B's, and you see your standard error, the mean, SE, and then here you have your symbol for mean. And they give you that information, right? Then you read up about the memory of B's. You're not expected to know about the memory of B's. You're just applying how to do these confidence interval bars. So you're constructing your graph, right? So you label your Y and your X-axis, right? Appropriately include your units. You always put a title, and then you're going to graph it, and you would put in your standard error bars, right? And then you would describe the effect, right? What are you seeing? A short-term 10 minutes or a long-term 24 hours. You give a brief description of the experiment. You're identifying your null hypothesis, your control treatment, and predict what could be used to reject the null hypothesis. So remember, null hypothesis, you're not able to set up a control group here. So you're setting up a hypothesis that if you reject, that is going to therefore support the alternative. So you would say there is no difference based on the amount of caffeine on how the B's memory works. So again, here's one benefit, one cost. Here's another example. Here they are in a line graph, your standard error, the mean bars, and they're giving you the experiment. This was on vegetation. And then here they want you to analyze that and support using the data. Again, you want to take in the standard error mean, making a claim using the standard error mean and support, right, some data for that. And then describe one advantage based on that regulation. Now, this is not something we studied, but you know something about plants, you know about germination, or you will after next week, and you know how to read a graph. It's the kind of question that I'm thinking that they're going to go with. I'm not 100% sure. They will tell us hopefully April 3rd. Okay, not obviously the exact question. And here's another one from 2014. This is on trichome density. So those are those little hairs, if you remember, that are on some plants, and it makes it, like Liam's there, and it makes it difficult for the herbivores to eat them. So it's one herbivore protection. And you can see again, all right, you're doing a graph, you're putting in your error bars, right? And then looking at that in the error bars, you're identifying the two populations that are the most statistically different, meaning their error bars cannot overlap, right? And then describe your independent and dependent variables, identify an appropriate duration for the experiment. So how long should it occur? And then predict the experimental result that would support the hypothesis. You can see here you're graphing down here. So you can go through, practice those if you want. And if you don't want to practice them, at least I would recommend looking through them. Right. And again, if you want to go through these together during the class meeting, send me your question, tell me which meeting you're going to, and I'll make sure to have something like this set up ahead of time that we can just walk through together and that we can ask your questions in real time. That might be useful for you. But we're still getting the hang of this. All right. Hope that was helpful.